Good afternoon, student. Last class discussed about the demodulations, necessity of demodulations, rectification of demodulations, AM detector, and important of demodulation, that is the block diagram of super heterodyne receiver. And now today we discuss about the problematic of the communication and the use of modulations, modulation factor, demodulations, sideband frequency, and bandwidth. Now first problem we have to see that a modulated carrier wave has maximum and minimum amplitude of 750 millivolt and 250 millivolt. Calculate the value of percentage modulations. Now already see the modulation factor. Do you know the modulation factor? And modulation factor is defined the lower frequency to the higher frequency. You have to see the waveform, that is the carrier waveform, and the modulated waveform will travel to the both positive and negative side, and the center wave formations will travel to the this amplitude modulations. The distance will be varied, and this is the lower, that is the 250 millivolt, and this is the higher, and this is the 750 millivolt. So we have to see the formula. We have know that already, that is the Vc maximum is equal to 750 millivolt and Vc minimum is equal to 250 millivolt. Therefore the modulation factor is equal to V maximum minus V minimum divided by V maximum, Vc maximum plus Vc minimum. But we have to calculate percentage of modulation, so into 100. So apply the V maximum is 750 minus V minimum is 250 divided by 750 plus 250 into 100. Then we get the calculate, that is 750 minus 250 500, and 750 plus 250 250 into 1000 into 100. Then we get the calculation, we get the 50 percentage. This is the percentage of modulation factor. This is the first one of the modulation of the carrier wave has a maximum amplitude and a minimum amplitude to find out the modulation factor. And now second one, a 10 megahertz sinusoidal carrier wave of amplitude 10 millivolt is modulated by a 5 kilohertz sinusoidal audio signal wave of amplitude 6 millivolt. Find the frequency components of the resultant modulated carrier wave and their amplitudes. So we have to see that first what is given. They have to find out the LSB and USB and the amplitude of the lower sideband frequency and upper sideband frequency. See the diagram of the sideband frequency, that is a frequency amplitude modulation of a frequency spectrum. This is the LSB and this is the USB and this is the carrier wave. Here what is said, a 10 megahertz sinusoidal carrier wave. So Fc is equal to 10 megahertz carrier wave and amplitude 10 millivolt, that is the amplitude of the carrier wave is 10 millivolt, is modulated by 5 kilohertz, and the modulated of the carrier wave is 5 kilohertz. So we get the megahertz, so 0.005 megahertz. Then wave of the amplitude 6 millivolt. What is the volt in the 6 millivolt? Find the frequency component of the resultant module wave and their amplitude. Spectrum amplitude ಗಳನ್ನು ನಾವಿಲ್ಲಿ find out ಮಾಡಬೇಕು. Now first of all, then first what we have to see the first one, the original carrier wave frequency fc is equal to 10 megahertz. Okay, and second one, USB frequency. USB frequency means fc plus fs. Fc is 10 plus fs means fm, that is 0.005. We get the 10.005 megahertz. And second one, LSB frequency is equal to fc minus fs. 10 minus 0.005 is equal to 9.995 megahertz. Okay, see the diagram. This is the 5 kilohertz distance. Okay, this is the 5 kilohertz. USB is 10.005 megahertz. LSB is 9.995 megahertz. And what is the LSB of the amplitude? That is MVC divided by 2 and MVC divided by 2. How much will getting the amplitude of the frequency of LSB and USB? So frequency spectrum, we have to see the frequency spectrum. This is the 10 megahertz of the frequency spectrum. So we have to find out the frequency spectrum of the modulation factor. M is equal to B divided by A. We have to know B is a 6 divided by A is a 10. That is a 6 millivolt divided by 10. Then we get the 0.6. So factor, that is the amplitude of USB and LSB is equal to MA divided by 2, and M is 0.6 into A is 10 divided by 2 is equal to 3 millivolt, and USB and LSB is equal to 3 millivolt of the amplitude, and USB is also 3 millivolt of the amplitude. This is the resultant modulated wave and their amplitudes. So easily we have to find the amplitude of the modulated carrier waves. Okay, this is the second one problem. And next one problem is an audio signal given by 50 sin 25 2000 t amplitude modulates a sinusoidal carrier wave 60 sin pi 1 lakh t. Determine the modulation index, percentage of modulation, frequency of signals and carrier, and frequency spectrum of the modulated wave. See, we have to say the equations of the carrier wave. We are already known that is the small e is equal to capital EC cos into omega ct plus of c. This is the carrier wave equations. So here we have to take the value of EC of the carrier wave, that is defined as value B is equal to 15, and amplitude of the carrier wave, that is the A is equal to 16. That is the second one of the amplitude modulated of the carrier wave. And what is the first one? Modulation index. What is the first one? Modulation index. Modulation index is equal to delta f s divided by delta fc. We have to define the in the case of modulation factor and modulation index. And now we have to define that delta fs means that is the carrier frequency signal of the amplitude. So we get the carrier frequency of the signal b, that is we have to define modulation index is equal to b divided by a. So b is equal to 15 divided by 16 is equal to 0.25. and second one, B, percentage of modulation factor. We have know the modulation factor of percentage modulation index into 100, and modulation index into 100 is modulation index is 0.25 into percentage of modulation factor is equal to 25 percentage. And the third one, frequency of signal. Frequency of the signal is fm is equal to equations. So we have known that omega that, so that is 2000 hertz by inspection of the given equations. And the second one, fc is equal to 1 lakh of the hertz by inspection of the given equations. So we know that we have to find out the frequency spectrum of the modulated wave. Frequency spectrum of the modulated wave, to find out that, so we have to take on the first one is the 1 lakh hertz. We have to convert that, that is 100 kilohertz, first one. And second one, LSB 1 lakh minus USB plus 2000 is equal to 1 lakh 2000 hertz. We have convert that, that is 102 kilohertz. And third one, 1 lakh LSB minus 2000 is equal to 98,000 hertz is equal to 98 kilohertz. To find out the different types or varies of the USB and LSB. This is the upper sideband frequency and this is the LSB lower sideband frequency. See the for problems once again. An audio signal given by 50 sin 25 2000t amplitude modulated a sinusoidal carrier wave 60 sin pi 1 lakh t. Determine the modulation index, percentage of modulation, frequency of signal and carrier, and frequency spectrum of the modulated wave. So we have to know the carrier wave of the equation small e is equal to EC cos omega ct plus C, and we have to know the amplitude modulation of the carrier wave also. So we have to take on the modulations of the signal small b capital B is equal to 15, and amplitude modulated carrier wave of the amplitude A is equal to 60, and modulation index is the delta fs divided by delta fc. So we have to take the b divided by a, then we get the modulation index, and the modulation factor in the case of percentage into 100 of the modulation index. So we getting the 25% of the percentage. And third one, frequency signal and the carrier. Frequency signals of the carrier in the given equation 150 sin 2 pi 2000t of the modulation frequency is at 2000, and the second equation of the amplitude modulation of the frequency is 1 lakh, that is defined as the carrier frequency fc. So we have to convert the carrier frequency 1 lakh hertz to kilohertz to that is the 100 kilohertz. Then USB is the fm plus fc and fm minus fc. So get the USB upper sideband frequency and lower sideband frequency. This is the find out the fourth cases of the amplitude modulations of the frequency spectrum of the LSB and USB. And next one, easily we have to find out the bandwidth and modulation index. See the problems. An audio signals of 1 kilohertz, that is the audio signals of the 1 kilohertz are used, that is fs is equal to 1 kilohertz. To modulate a carrier wave is 500. Carrier wave, that is fc, is equal to 500 kilohertz. Find out the USB and LSB and band width. The first one, USB is equal to fc plus fs. Substitution, 500 plus 1 is equal to 501 kilohertz. Second one, LSB is equal to fc minus fs is equal to 500 minus 1 is equal to 499 kilohertz. And bandwidth is equal to 2 into fs. 2 into fs is equal to 1 kilohertz. So we getting the bandwidth is 2 kilohertz. This is a bandwidth, this is upper, lower, this is a upper. And take the spectrum lines, that is a carrier frequency, that is a carrier frequency is a 500 kilohertz, and this is the USB, and this is the LSB. LSB is a 499 kilohertz, and USB is the 501 kilohertz, and carrier frequency of the bandwidth is the 2 kilohertz. This is the, you find out the USB, LSB and bandwidth. And next one, fifth one, calculate the modulation index for an FM wave. Calculate the modulation index of the FM wave, modulation index, where the maximum frequency deviation, that is a delta f is equal to 50 kilohertz, and the modulating frequency fs is equal to 5 kilohertz. So we get the modulation inductor is equal to delta f divided by fs. Delta f is equal to 50 kilohertz and fs is equal to 5 kilohertz. So we get the 10 of the modulation index. In factor 10 into 100, then we get the 1000 or 10,000, then that is the answer of the modulation index and modulation factor. Okay, thank you student.